Alright, so in this video I'm going to go over the RC circuits. And so we are discharging. When we discharge, there is only one behavior, and that is exponential decay. So if this is time t, and here you have parameter x, it will decay exponentially, like so. So x of t is x0 exponential minus t over RC time, which is tau. So the x is the variable, and x0 is the maximum value at time t equals 0. Example, I can apply this electric current. I of t is the I0 exponential minus t over RC. It is the same thing for the charge, the voltage across R and C. Same behavior, same equation. Alright. Now at this point the circuit is open, so there is no current. At time equals 0, at the very beginning, I'm going to close the switch. Now when that happens, the current will flow throughout the circuit. So early on, the charge rush to the other side. If this is, let's say, plus, and this is minus, so the charge will rush the other side, and very quickly, and a lot of them. So you expect the current to be maximum. So what is that current? So you can just apply Kirchhoff rules and figure out this voltage here is exactly the voltage across R at t equals 0. And so the maximum current in the circuit is just that voltage, which is 24 over 3 mega. Mega is 10 negative 6 to the 6. And so this is now 8 micro amps. 10 negative 6 is a micro. So this is the answer. Alright, so this is the maximum current in the circuit. Micro is 10 negative 6 we put here. Alright, number two, so we answer this one. Number 2, what is the maximum charge? Well, the maximum charge Q, let's use this one here. The maximum charge, which is Q0, because the capacitor is charged earlier, so equals C times V max, where V max is 24 over V0. That is 10 microfarad times the V0 24. So I have answered this early on of the stage of discharging. That means the boundary conditions, if you wish, at t equals 0. If I wait long enough, there will be no current, no charge, no voltage, nothing. So this is, everything is maximum at the very beginning. And so what is this? This is 240 and microcoulomb. Let's put it here in a circle. All right. Let's do number 3 now. Number 3. So we're done with this here. Okay, number 3. What is the current after 15 seconds? So since I'm talking about the current, I'm going to use this equation. If it was about the voltage, then I put V is V0 exponent so forth. So let's do the current. So the current I of t when t is equal 15 seconds. So I'm going to substitute. So that is I0. We have calculated I0 to be 8 micro amps, like so, exponential minus t is 15 over RC. What is RC? The RC time is this, which is tau, the characteristic of the circuit. So R is 10 to the 6, and C, no, this is not 10 to the 6 times 3. Okay, let's try again. It's not true. Alright, so R is 3 times 10 to the 6, which is mega. So that is R, and C is 10 micro, and micro is 10 negative 6. As you can see, 6 negative is just 0, so this is just 30 seconds. So this is the RC time, and so I put here 30. And so this is like 8 micro. Let's see the time. We have time, micro amps, and then exponential minus 0.5. Minus 0.5. Alright, if you do the math, according to my calculation, it is 4.85 or 89. Yes. And so micro amps. It's almost 50%, obviously, because the RC time is that half. All right, number 4. I'm going to use this one here. Number 4. Now, here you have to pay attention. Very likely you are going to have a question like this. So, here is the question. How long will it take for the capacitor to discharge 12% of its maximum charge? The equation of Q of t for any time t has the behavior of x of t, which is the maximum charge Q0, which is x0, exponential minus t over RC time. So this is the behavior. This is how the charge will decay exponentially. Now, when this is 12%, that means 12% is 0, 12 of Q0. That's why it means 12. That means Q0 divided by 100 times 12, or just, yeah, times 12 over 100. So 0, 12 Q0. So this is equal to Q0 exponential minus t over RC time. Now I lose Q0 and Q0, so I'm left with 0.12 equals exponential minus t over RC time. We are looking for the time here. So take the natural log for both sides. So natural log of 0.12. All right. And so the natural log of this is just minus t over RC. At this point, we can solve for t. It's really easy. So it's minus RC and natural log of 0.12. All right, so RC is 30. We have called RC is here. So t is minus 30 seconds, natural log of 0.12. Let's do the math. What is it? Okay, I did the math here. Almost 64 seconds. Almost. Is it? Yes, 64 seconds. All right. And if I went longer, probably there will be no charge. So this is the kind of question you expect. So here I can ask more questions. For example, what is the voltage? Let's say after 2 seconds. What is the voltage across R? I'm going to use the same equations. Okay.